All right, greetings, seventh grade. Hope you're doing well. Hope the test went well for you. If you're doing that on electronically, answer the questions on the Google Forms. I'll get that printed out. It might not be until later today, but I'll get those printed out and get them graded and make some notes in classroom. Maybe indicate some problems that you could look at again. If I tell you to recheck one, don't use your book, don't use mom and dad, don't use Siri or Alexa or Google, and you can see if you can find mistakes. If you ask any questions, you can ask them of me out on Classroom or email or Dojo, okay? So I want to talk with you today about, we're getting into the next chapter, and I'm pushing you out there. And so begin Wednesday. If by Sunday you could have chapter 9 done, be ready to take the test first part of next week, okay? But let's take a look here at, if we look at 9.1, which starts on page 384. This one should go pretty fast, okay? So notice it's area of rectangles and squares. So this should not be new to you. So whether it's a square or a rectangle, all right, you're used to probably the first formula or equation that you learned for area was the length times the width. Okay? And so then later, if you haven't caught it yet, instead of calling this length and width, we're switching over to the base and the height. Because if we define those, it really doesn't matter whether it's the long side or the short side, or if they're all equal sides. It doesn't matter. It's just the one that it's sitting on at the time. Okay? So the base and then the height is always from the base up at a 90-degree angle. Okay? So that will work for everything. So what you should be used to, get used to, if you haven't yet, is that the equation would be the area of a quadrilateral is base times the height, BH. Okay? Now, the only thing that causes some problems sometimes, and all, is if you have something that's irregular shaped. All right? And if you remember from before, but if not, here's just a little reminder. I can divide these into quadrilaterals. Okay? So then I'd be finding the area of that section, the area of that section, the area of that section, and then I'd just be adding those sections together. That's going to give me my total area. Okay? Now, some of you might recognize that, and you might want to, and it really doesn't matter, divide it that way. Okay? And then your area would be of this section, and this section added together. Doesn't matter. Okay? You're just dividing it at this point you're dividing it into quadrilaterals. And then, because you can find the area of a quadrilateral. And then just don't forget that when you get your area, it's going to be something squared. Because you're taking inches times inches, feet times feet, miles times miles, centimeters times centimeters, whatever. So it's going to be square. That's not the same as 2 times. Okay? All right. So if you turn over to 9.2, and 9.2 starts on page 288, and you're going to see, and this is the areas of parallelograms and triangles. So I brought along a couple of visuals here to help us to understand parallelograms and quadrilaterals. So let's start off with parallelograms first. Okay? So on the parallelogram, and we can just put this right here. On a parallelogram, looking something like that, all right, your base is still going to be the same. So that's that entire part there that it sits on. Okay? But what we're going to do with the width, some people might want to measure this thing like here and call that the width. Okay? That's not going to give you an accurate measurement. So if you recognize that's actually a right angle, and this edge is the hypotenuse. And remember, the hypotenuse is the longest side on a right triangle. So that's going to be different than the width. So that's why we're switching over from length times width to base times height. Because this is the base, okay? And the height is actually a perpendicular line from one corner, one bottom corner of the parallelogram up. This has to form a 90-degree angle. It has to be a perpendicular line. And then that's defined then, the height is the distance from the base to the top along a perpendicular line. Okay? Now, why does that work? Watch through the magic of modern science and the amazing abilities of Mr. Kent. Watch, I can take this off of this side, stick it over here, and look what I get. A rectangle. So, whoops, all right, until it falls off. So that, then you can see that this line right here is your width or the height. Okay, so rather than having to cut this thing apart and move it, and we wouldn't be too excited if you did that with your book, okay, you can leave it like this, but just measure that height. You can measure it on this side, okay, from this corner down at a 90-degree angle, or on this side from this corner up, 90-degree angle. Either way, that's your height. So that's why we switch our formula. So looking at it like that, and that's the proof, then the area of a parallelogram is base times the height. Okay? That's your proof, and that's what you do. Same formula. Base times height. Okay? So then we get to a triangle. All right? And again, a little visual to help us see this is, so first of all, think about a rectangle. Again, base times the height. But then, look what happens if I cut that rectangle in half. I get a triangle. And so, a triangle is half of a rectangle. Okay? So, if it bothers you, we can flip this around. And go like that. Okay? So here's the part that it's sitting on. Here's the base. Here's the height. Base times the height would be the area of the rectangle. The triangle is half of it. So the area of a triangle is 1/2 the base times the height. Okay? And that's the formula. Thank you. Thank you. I'll be here all week. So, all right. Hope that helps you with that part. Okay? It's really pretty simple when you look at it that way. And, you know, when people, they'll sit there and go, oh, it has to be harder than that. And they sometimes, their brain will play tricks on them and they'll actually make it harder. Okay? So then let's just go ahead and go over to 9.3. Starts on page 393. Okay? And so when you look at, I'm going to erase part of this, if you needed some of that, you could always rewind the video and repeat some of that. Okay? Let's talk about a trapezoid. So a trapezoid, what we're used to on a trapezoid is something shaped like that, right? Whether it's upside down or not, or on its side. Okay, and a trapezoid by definition has one pair of sides, opposite sides, that are parallel. Now notice that they're not the same length, are they? So we're not going to be able to take base times the height. At least not in that form. Okay? Some of you might see that in this trapezoid, okay, this one's perfect to where I could just take this and divide it here and divide it here. And so I've got a base here. We can call that base 1. Okay, and I've got the height. Okay, I could call this base 2 and still the same height. I could call this base 3, still the same height. So now I could find the area of this part by base 1 times the height. I could find the area of this piece by base 2 times the height. Now, if these are exactly the same size, I could do 2, 1/2 the base times the height. Okay? Or I could just do 1/2 the base times the height and 1/2 the base times the height. So that would be the area of B1 plus the area of B2, okay, plus the area of B3, and that would be the area of the whole thing. Now, they show you a trapezoid that's not regular shaped. So, in that case, you still divide this on the perpendicular, and you have two triangles, but they're not the same size. Okay? So, they show you that you could have base 1, you could have base 2, okay? And, okay, and, let me see. I didn't draw it. Oh, I'm sorry. Well, yeah. So, they have it like that. And then what they're showing you is that if you straighten this out, add this piece to make a rectangle, okay? This base 2 is the same as this base 2, okay? And so what they're doing is they're taking base 1 and, I should draw this differently. Sorry. Okay. They're taking, let's see, base 1 and base 2, and they're calling this base 2. Okay. And so what they're doing is adding these two together and then divided by 2. So what are they doing? They're averaging this base 1 with this base 1. Okay? They're averaging those two bases, okay, times the height. So they're showing you a formula, okay, of, now they could show it to you this way, base 2 base plus base 2 over 2, sorry, base 1 plus base 2, okay, over 2, okay, because you're adding them together and then divided by 2, and then you're taking that times the height, which the height is the same no matter how you do it. Okay? And so the other way to write that would be 1/2 base 1 plus base 2, okay, times h. Okay? And they're putting the base 1 plus base 2 in there over 2. Oops, like this one. Or they're taking 1/2 base 1 and base 2. Either way, okay? So this will work. Doing it this way will work, okay? Because what they're doing here if you took that and copied it and laid it over here. I see, I didn't draw that very well. Partly because my thing over here is running in. So what they're trying to show you is this is the same as this piece over here, which is missing. Okay? So that's why they're taking base 1 plus base 2, averaging them, okay, and then times the height. All right, sorry, my drawings are just a little weird. So, okay, hope that helped you and didn't mess you up, okay? So, all right, if you have any questions, ask, okay? And we'll see you out here tomorrow.